Okay, problem 6.1.14. The first problem, I believe, in lesson 6-1. Supposed to find the domain range, the x-intercepts, the asymptotes for this problem. And you see a sample of what the formats are there that you can use. But just a reminder that in the exponent of the 7, you can put any number up there that you would like. Negatives, positives, decimals, fractions. So that's why this correct answer right here is the all real numbers. Domain means x. What can you put in for x? The second part down here, it says, well, what about the range? So the answer, the y. So your y's for this 3 times 7 to the x. If you think about the exponential problem, the exponential growth, that means that when x is 0, for example, that you're going to have 7 to the first 0 is of 1. So you're going to be up at like 3 here. And you know, 7 to any power, this whole thing's got to come out to a positive number. So as long as it's any positive number, you could get a fraction or a decimal. It's going to come out here, but then it's going to shoot up forever. So you're going to end up going to a positive infinity. So my choices here is y equals 0 or y equals a specific number. It's greater than a certain thing. It doesn't equal something, or it's less than something. So when you have that y ends up equaling 3 times 7 to the x, and you know, you can throw that in decimals or something if you want to graph it and look at it. But it's going to be out there on the left side, going down to the asymptote of being greater than 0, because your x-axis there is your asymptote. So that takes care of the domain, the range. My x-intercepts, we talked about that right there. So my y-intercept when x equals 0. Y equals 0, this will never have a solution for that because the y equals 0 is the x-axis. So there are no x-intercepts. And the asymptote, we already mentioned that's the x-axis for the horizontal asymptote. There is no vertical. And just a reminder that the x-axis asymptote is when y equals 0. So I think that answers. Then describe the end behaviors. So the end behaviors here on the right as x goes to a positive infinity, you know, out here, the y goes to a positive infinity as well. And on the left side, as x goes out there to a negative infinity to the left, then your y out there is approaching 0. It's getting closer and closer to the x-axis. So I believe that answers all of the questions in the initial part of that problem.